These are some applications of electromagnetic waves. Click on each image. Electromagnetic waves play a great role in our life. Can you name some uses of electromagnetic waves in our modern life? Answer: telecommunication, preservation of food, microwave cooking, and medical treatment. Introduction. In this lesson, you will learn to understand electromagnetic waves are made up of electrical vibrations and magnetic vibrations. Understand the orientation of E and B in an electromagnetic wave. Compare electromagnetic waves with mechanical waves. State the formula C equals 1 over square root of epsilon naught mu naught. State the order of magnitude for wavelength of each type of electromagnetic wave. James Clerk Maxwell was born in Edinburgh, Scotland. From a very young age, he showed a great flair for mathematics, and he had a mathematical paper published at the age of 14. He studied at Cambridge University, where he soon became professor of physics. According to Faraday's law, a changing magnetic field produces an electric field. In 1864, Maxwell hypothesized that a changing electric field should also produce a magnetic field. The dipole antenna is a simplified version of broadcasting antenna used to transmit audio and video signals. The amplitude or frequency of the signal is modulated to transmit the information. The figure shows a dipole antenna with M charged positively and N charged negatively. Click the Animate button to observe the electric field E produced by this arrangement. The electric field produced by a dipole will eventually disappear at great distances. Click the Reverse Polarity button to reverse the polarity of M and N. What happens to the electric field now? Answer: the electric field is in the opposite direction. Click the Animate button to observe the magnetic field B produced by this arrangement. The magnetic field is maximum when current I is maximum. Click the Reverse Polarity button to reverse the polarity of M and N. What happens to the magnetic field now? Answer: the magnetic field is in the opposite direction. It is due to this magnetic vibration that the electric vibration is generated. Summary: electromagnetic waves are made up of electrical vibrations and magnetic vibrations. This animation shows the orientation of the electric and magnetic field vectors in an electromagnetic wave. In which direction is the wave propagating? Answer: the X direction. In which direction is the electric field vector vibrating? Answer: the Y direction. deselect the electric field checkbox. In which direction is the magnetic field vector vibrating? Answer: the Z direction. Click the electric field checkbox. Electromagnetic waves consist of electric field and magnetic field that oscillates sinusoidally. Are electromagnetic waves transverse or longitudinal waves? Answer: electromagnetic waves are transverse waves because the electric and magnetic fields are vibrating perpendicular to the direction of propagation. What do you notice about the phase between the electric and magnetic field vectors? Answer: the electric and magnetic field vectors are always in phase. The two reach the maximum and minimum vibration values together. What do you notice about the frequency of the electric and magnetic field vibrations? Answer: the electric and magnetic field vectors have the same frequency. Click the equation button to view the progressive wave equation representing the electric and magnetic vibrations in the electromagnetic waves. The direction of propagation of electromagnetic wave can be determined with the help of the right hand rule. The forefingers of the right hand points in the direction of the electric field E. The fingers are curled toward B, and the thumb will point in the direction of propagation. Click the cross product button. The cross product E cross B always gives the direction of propagation of the wave. Drag to rearrange the properties of electromagnetic waves so as to correspond with those of mechanical waves. Summary: the electric and magnetic fields E and B are always perpendicular to the direction of propagation of the wave. The cross product E cross B gives the direction of propagation of the wave. Equations for the electric field E and the magnetic field B of an electromagnetic wave are: E equals E naught sine kx minus omega t, and B equals B naught sine kx minus omega t. In 1865, Maxwell predicted theoretically that electromagnetic waves propagate through a vacuum at a speed c, a large and finite value. All electromagnetic waves travel through vacuum with precisely the same speed c, which equals the speed of light in vacuum. Click the expression button to observe the expression derived from the Maxwell equations. Click the Substitute and Calculate button to substitute the values of epsilon naught and mu naught respectively into the expression. We find that the value of C is 3 times 10 to the power of 8 meters per second. We find that the theoretical value of C agrees with the speed of light determined experimentally. This leads scientists to believe light is a type of electromagnetic waves. Summary. The formula for the speed of light, c, is given by c equals 1 over square root of epsilon naught mu naught. The formula c equals 1 over square root of epsilon naught mu naught leads scientists to believe that light is a type of electromagnetic wave. Electromagnetic waves exist across a broad range of wavelengths called the electromagnetic spectrum. Within the spectrum, the waves are categorized according to their frequency range. Move the slider across the electromagnetic spectrum and observe the types of waves. The visible part of the spectrum with wavelengths from 400 to 700 nanometers is particularly important to us because these are the wavelengths which the human eye can detect. Drag the slider to observe the relative sensitivity of the average human eye to electromagnetic waves at different wavelengths. Which part of the visible light spectrum is most sensitive to our eyes? Answer. The yellow-green part of spectrum of wavelength 555 nanometers. Drag the types of wave to the correct order or wavelength with the longest at the top. Key in a typical order of magnitude for each type of the electromagnetic wave. Summary. The electromagnetic waves are categorized by the wide range of frequencies and wavelengths. The frequency of an electromagnetic wave can have any positive value, and this full range of wavelengths or frequencies is known as the electromagnetic spectrum.